Now that we know how to find missing sides and angles of right triangles, we're going to look at how do we find missing sides and angles of non-right triangles. So we're going to be starting out today by using the formula of law of sines to find our missing sides and our missing angles. So just a reminder that when we use our SOHCAHTOA, our sine, cosine, and tangent of the opposite, the adjacent, and hypotenuse, that only works for when we're working with right triangles. So when we have a non-right triangle we're trying to find the side of, we need to go to a different formula, which is going to be the first one that we talk about today, which is our law of sines. The law of sines consists of three ratios making a proportion, and what they're doing is they're taking the sine of angle A over little a and setting that equal to the sine of angle B over little b, sine of angle C over little c. A, B, and C should be fairly self-explanatory of where those are. Those are the angles on your triangle. Now where little a, little b, and little c are, those are the side lengths. And little a, what that is the side that is opposite of angle A. Little b is the side that is opposite of angle B. And then you have little c, which is opposite of angle C. And we have now our ratios and a proportion that we can then solve. So I'm going to go through a couple examples of how to find missing sides and also how to find missing angles. So here I have triangle ABC. We have two angles, angle B and angle C. And we are trying to look for x here, which x is going to be little c, since it's opposite of angle C. I am given 7 here, which is opposite of angle B, which means that that's giving me little b. When I look up at the formula up on top, I can replace angle B with 44 degrees. I can replace angle C with 53 degrees. I can replace little b with 7, and I can replace little c with x. What I have now is two complete ratios, which allows me to then solve for x. So I have the sine of 44 divided by 7 is equal to the sine of 53 divided by x. With our ratio that we have, or our proportion, sorry, we can go ahead and cross multiply to help us solve. So x times the sine of 44 is equal to 7 times the sine of 53. I'm going to divide both sides of our equation by the sine of 44 degrees. And then to get our answer for x, we're going to go to our calculator. When you are working with these, we want to make sure that we don't round our answer until the very final step. So I'm going to go ahead and take 7 times the sine of 53. I'm going to go ahead and hit enter, get my answer, take that answer times the sine of 44. Hit enter one more time, and I get 8.05. And so there's how we're finding our missing side. If I go to another example here where we're trying to find again a missing side, looking at the information that's given to us, we're given that angle B is 57 degrees. We're given that angle C is 39 degrees. I'm given that little a is 27. And we're looking to solve here for x, which is going to be little c. When I look at my formula that I have up above, I have really only one complete ratio, the sine of 39 degrees over x. The other two ratios are not complete, and so I cannot use my proportions to be able to solve this unless one of those is complete. So we have to think of, well, what other information do I know? And the fact that they give you 2 of the 3 angles, we can go ahead and find the third angle. We know that the 3 angles of a triangle have to add up to 180 degrees. So take 180 degrees, subtract 57 degrees, subtract 39 degrees, and this will end up giving us angle A. So if we take 180, we subtract 57, and we subtract 39, I end up getting left with 84 degrees. So I know that angle A has to be 84. This creates a complete ratio to allow us to set up the proportion. So I have the sine of 84 over 27 is equal to the sine of 39 over x. We're going to cross multiply. x times the sine of 84 is equal to 27 times the sine of 39. Divide both sides of the equation by the sine of 84. And now we just need to go to our calculator to find our solution. So again, we're not going to round until the last and final step. So 27 times the sine of 39. Take that answer, divide it by the sine of 84. And we get 17.09. So there we've gone through two examples of how to find a missing side. Now we're going to go ahead and look at how do we find a missing angle. It's the same type of step that's being used, but now we're just going to be looking for an angle rather than the sides. So filling in the information that we know that angle A is 82 degrees. I'm trying to find angle C. We know that the side opposite of angle A is 29, so that means little a is 29. And the side opposite of angle C is going to be 24, so little c is 24. So here I have my two ratios that we can set up our proportion. The sine of 82 over 29 is equal to the sine of x over 24. Since we have a proportion, we're still going to cross multiply to get rid of our fractions. 24 times the sine of 82 is equal to 29 times the sine of x. Now, rather than solving for a side, we're solving for an angle. So what we need to do here is get the sine of x all by itself. So I'm going to divide both sides by 29. This is going to give me what the sine of x is equal to. So I'm going to end up with multiplying 24 times the sine of 84 and dividing that by 29. So I'm going to go ahead and put that into our calculator. 24 times the sine of 84. Find that answer, divide that by 29, and here we get a decimal. Now this decimal is not what our angle is. Remember that when we find angles, this is where we're going to use our inverse sine. So I'm going to take the inverse sine of this answer that I just plugged into our calculator, and what that's going to do is that's going to end up giving us our angle for x. So I'm going to hit second sine. There's my inverse. I'm going to grab the previous answer that my calculator had, and then I'm going to hit enter, and I get 55.4 degrees. So just like when we were working with right triangles, when we're trying to find an angle, that's when we're going to use our inverse to find that angle. That's what we're doing here. So just to go through one more example of finding a missing angle, just so that you have this down. Here I've got a triangle where I have angle A, which is 129. I have little a, which is 33. We're trying to find angle C, but I do know that little c is 25. So I have two ratios making my proportion of the sine of 129 over 33 is equal to the sine of x over 25. To solve our proportion, we're going to cross multiply. 25 times the sine of 129 is equal to 33 times the sine of x. To get our sine of x by itself, so that we can then do the inverse, we're going to divide by 33. Going to our calculator, 25 times the sine of 129, take that answer, divide it by 33, and we're going to get a decimal. Now this value right here is equal to the sine of x, so by taking the inverse sine of that answer, that decimal, I'm going to get my angle of 36.07 degrees. And so there we just found the missing angle. Now that we've gone through this, we've seen 2 examples of finding a missing side and 2 examples of finding a missing angle. If you're struggling with this, go back, watch those examples again, and if you have any questions, bring those with you to class tomorrow.